Hi, hello everyone. This is Vamsi. Today's our topic is interrupts. What is interrupts? An interrupt is a signal directed to the processor by either hardware or software signifying an event that requires immediate attention. This signal causes the processor to pause its current activities momentarily so that it can address the event. Once the necessary action have been taken, the processor continue with its priority task. Basic concepts and importance. When an interrupt happens, the processor halts its current instructions and saves its state to returns to the same point later. It then runs a specific set of instructions known as an interrupt service routine, which is called ISR or interrupt handler to manage the interrupts. Once the ISR is completed, the processor restores the previous state and resumes its original task. Some of the interrupts about this concept. Interrupt occurrence. When an interrupt occurs, the CPU pauses its current operations to address the interrupting event. States saving. The CPU saves its current state, including the program counter and register to ensure it can return to the same point after handling the interrupts. The third one is executing ISR. The CPU runs a specific set of instructions called interrupt service routine or interrupt handler, which is designed to address the particular interrupts. State restoration. After the ISR complete its task, the CPU restores its previously saved state to continue from where it left off, resuming tasks. The CPU resumes its original operations, ensuring that the interrupts is handled promptly without losing track of the ongoing processes. And the next topic is differences between the hardware and software interrupts. Interrupts. In hardware, we have two subtopics: external or interrupts or internal interrupts. In software, there is a subtopic program generated. In this, generated by an IO subsystem. In internal interrupts, in malfunction detected by CPU hardware generated interrupts. In program generated by user programs using INT. In external or interrupts, they communicate successful completion of IO. Ready status for interrupt driven. An error in IO. And these are in internal interrupts. There is an example: divide, overflow, arithmetic errors, invalid instructions, and etc. In debug mode, operations of program causes and interrupts. In program generated, useful for system calls. In second, and this feature is required while writing device drivers. In hardware interrupts, um, hardware interrupts is initiated by external hardware devices such as keyboard or mouse to indicate events like key press or data transfers. These interrupts signal can processor to address hardware related activities. They are essential for real time responses to external events. Typically, hardware interrupts have higher priority and are in, asynchronous. Software interrupts. Software interrupts are generated by the programs or the operating system to manage system calls or handle exceptional condition with the software. These interrupts allows the processor to perform tasks like memory management and input and output operations. They are useful for innovating system services and managing software events. Generally, software interrupts are synchronous synchronous and have a lower priority compared to hardware interrupts. And the next one is types of interrupts. In types of interrupts, there are two two types. One is hardware interrupt and software interrupt. In hardware interrupt, we have two sub concepts. One is maskable interrupts, and second one is non-maskable interrupts. Firstly, we go through on hardware interrupts. Hardware interrupts are signals from hardware device that demands immediate attention from the CPU. They are triggered by events like data reception by a network card or key press on the keyboard. When such an interrupt occurs, the CPU temporarily halts its current operations to address an hardware's request, ensuring promote handling the critical tasks. The examples are keyboard interrupt generated when a key is pressed on the keyboard. Timer interrupt generated by a system timer at regular intervals for the task scheduling. Network interrupts generated when a data is received by an interrupt interface card. For example, when you type on keyboard, the hardware interrupt is triggered to handle the input and update the system accordingly. And the second one is software interrupts. In software interrupts are initiated by the software instructions to execute system calls or manage errors. For instance, the INT instructor in x86 assembly language generated a software interruptions. These interrupts enable a software to request operating system services or handling exceptional conditions effectively. For example, system call interrupts invoked by applications to request services from the operating systems. In this example, file operations and process management. The second example is exception handling interrupts used to manage errors or exceptional conditions encountered during the program execution. And the maskable and non-maskable interrupts. Maskable interrupts. These can be ignored or delayed by the CPU, typically controlled via interrupt masks. For example, an interrupt from a printer can be masked if the CPU is handling higher priority tasks. And non-maskable interrupts, NMIs. These cannot be ignored and must be processed immediately. Used to critical events such as hardware failures, for instance, a priority error in the memory generated as NMI. Example, power failure interrupts that needs immediate handling to prevent data loss or system damage. And the next topic is exceptions. Exception refers to the specific conditions detected by the CPU during programming execution, such as divided by zero errors or invalid memory access. For instance, accessing a null pointer in a program triggers as a segmentation fault exception. These exceptions interrupts the normal flow of execution and typically requires specialized handling to resolve or recover from the encounter issues. Examples are a division by zero exception. It occurs when a program attempts to divide any number by zero, which is undefined in arithmetic operations. This error typically causes the program that halts its execution and may require handling through exception mechanism to prevent unexpected behavior or crashes. In the second next topic is interrupt handling processes. Handling by the operating systems. When an interrupt occurs, the operating system prioritizes it based on its type and direct the CPU to suspend its current task. It then executes the corresponding interrupt handlers or ISR, which is a specialized routine designed to manage the interrupt specific tasks. Role of interrupts handler. The ISR responsible for the acknowledging the interrupts, saving the state from the interrupted process, executing the necessary actions such as reading data from the device and restoring the state of the interrupted process once the ISR completes execution. Steps in the interrupt handling processes. Interrupt detection. The CPU detects an interrupt signal from the hardware devices or software request. Interrupt acknowledgement. The interrupt controller identifies the interrupt source and informs the CPU. Interrupt service routine ISR execution. The CPU transfers control to the ISR, which performs the required action. Context switching. If necessary, if necessary, the CPU saves the current process state, allowing its resume later. The next topic is interrupt completion. Once the ISR finishes, the CPU restores the saved state and resumes the interrupted processes. Resumption of execution. The CPU resumes the interrupted task from where it left off, ensures seamless continuity of operations. The next topic is importance and applications of interrupts. Importance in modern computing. Interrupts are crucial for real-time responsiveness and efficient multitasking in operating systems. They enables devices to communicate asynchronously with the CPU, ensuring timely processing of events without the need of continuous polling. In the real world, the last one is real world applications. Next one is networking. Interrupts are used to extensively in the networking of handling incoming data packets, ensuring promote processing and response times. The second one is user input device. Keyboards and mice rely on interrupts on signal users' actions, allowing the system to respond instantly to inputs. The last one is hardware errors. Non-maskable interrupts are vital for detecting critical hardware faults such as memory errors or overheating conditions, ensuring system stability and reliability. Thank you everyone. This is our today's topic.